Let's take a brief look at managing Cisco Umbrella. In order to manage Umbrella, we're going to go to this dashboard, which is actually just found online. It's a cloud-based dashboard, so we'll hit the portal, we'll go ahead and authenticate. When we do, we'll see our policies, and we can come in and customize these policies, reconfigure them, see who they're applied to, view our various logging, tie into Active Directory if necessary, set up custom block pages. Really, all of our administration and management is going to happen here. Notice that you got different policies there on the left: the CC on-premise, lab policy, BT on-premise, BT roaming, and then finally the default policy. Basically, whenever a connection comes in, it can only match a single identity as far as a decision-making process is concerned. But as far as a matching process, it might potentially match multiples. So it's important to create this list in order of preference. We want our most preferred list, or preferred entry, there at the top. Now, as far as configuring it, okay, we go in, we make our configuration changes within the portal. Once we apply those changes, they're going to be pushed to all the other towers. It's what I hear most people calling it. I'm not sure if that's the official term, but kind of slang like a cell phone tower. These are proxies where, as users are out in the field, they need to figure out who to connect to. They're going to have a list of possible servers, just like in a video game where you can look at latency and pick the closest server to you. You can do something very similar to that. But in our case, it's a bit more exciting because many DNS operations, we're going to leverage Anycast. So if you're familiar with Anycast, you can go ahead and continue with the course, jump into the next video. But if you aren't familiar with Anycast, if you said, wait a minute, you check your notes, you went through CCNA, and you go, yes, I know unicast, multicast, broadcast. What the heck is an Anycast? Just want to do kind of like a quick example here for you. So when we take a look at the internet, we know that the internet is made up of lots of different autonomous systems. So you've got your tier 1 providers, let's say like an NTT. And then you've got lots of other providers out there. And I don't want to start any fights with who's a customer of who or who's bigger in the scheme of things. So let's assume that they're all kind of equal. And we'll throw in Global Crossing. And we'll throw in, AT&T's got their own network. And we know that Level 3's got a network. And we know that Sprint's got a bit of a network. And we know that Comcast has got their own network. And this goes around and around and around. You've got your service providers and telcos. You've got people out there at the edge. But basically, we know that each of these autonomous systems are connected, not to all of each other so much in a full mesh, but they're pretty well connected to one another. And whenever they have an entry that they need to reach within our BGP tables, there's a good chance when I look at an individual IP address, I might have multiple paths to get there. I'm hearing about it from a lot of different sources, right? So we typically just use hop count, and then we can use a series of different metrics to select the best path. Well, one of the ways that we can achieve resiliency within the internet is through the use of Anycast. And Anycast is actually used on the root DNS servers. So you've got the root servers, which are named by alphabetical characters, A, B, C, L, M, etc. There's different organizations that run each of these root servers. And when you look at people like, I don't know, say ICANN, when we look at their network, they're going to say, hey, our DNS server, and they'll give you, give me 2 seconds, I'll pull up a real value. See if I can bring up a new Firefox window. Just bring this over here. And if you haven't been before, rootservers.org. This is going to show us a little bit about the DNS root servers that are out there. If we look at the bottom here, here's our list of A through M. So if we jump over to J, J is VeriSign. And if we look at the IP address, 192.58.128.30, like if right now you pull up a terminal and you trace route there, and I pull up a terminal and I trace route there, they're going to be different, unless you're in Tampa, Florida, like I am. Why is that? Because when I try to reach 192.58.128.30, remember, we're using BGP here. We hit our service provider, and our service provider looks at that IPv4 address and goes, oh, I've got 100 different ways to get there. It's going to pick the best path. So the way that I'd like for you to think about this, and if you've used like 4222 or 88888, these are very similar. Google's DNS server exists all over the internet. The whole idea of Anycast is that we take a single, and these just look like regular class A, B, or C public addresses. Sometimes they're catchy, like 8888, but all they do is they take that one IP address and they make it present in many different places. And if you haven't seen this before, you'd probably scratch your head and go, is that an IP address conflict? What's going on there? And it's not because they're not on the same broadcast domain. You're not going to have this issue where somebody ARPs and two different people answer. Because these are all in geographically different locations, and because they've all, and this is the part they don't always show you, there's a second IP. There is going to be, I'll just put GU for globally unique IP address. There's going to be one of these on each DNS server. They've got to have that. If they didn't and they sourced a packet from an Anycast address, who's to say if they'd ever get the answer? So you have this one globally unique address, do your software updates, do your synchronization to other DNS servers using your global IP. But you also have a second IP, an Anycast IP that you listen on. Should anybody ask for 8.8.8.8, you go, yeah, I'm right here. But again, because we advertise this Anycast address into BGP, BGP sees all these different paths to get there. So if you're a Comcast customer, you'll come over to here to this instance of it. If you're a Sprint customer, you'll come over to that instance of it. Really pretty slick, right? So Anycast has been used historically for many years for DNS, but I've seen network architects that do some pretty weird stuff, and they've been using it within their solutions as well. So realize that this is something that kind of underpins the way that DNS works. We use this all day, every day, just on the root servers alone. Then beyond the root servers, when you use public DNS servers, 4222, 8888, they're Anycast as well. Why are we talking about it here? Well, coming back, looking at Cisco's umbrella, they're going to give you an Anycast address for Cisco's DNS server. That DNS server lives in many locations around the globe. This ensures that when your workers travel from continent to continent, they can always find a nearby location to go ahead and do all of their lookups. Again, when we come in from a management perspective, maybe I'm down here in Tampa, I make my changes and I build my policy and I do all my logging and management here, but that's going to be propagated to the other data centers. It ensures that when my good friends down in Australia hop into the VPN, or in this case, Umbrella, and they start pushing their DNS through our servers, our policies that we've defined here in the States are going to be replicated down under as well. Really kind of slick.